Good morning. Welcome back to Botany. Today we're going to talk about germination. And germination is what we're going through right now because we have a germination. Okay. Anyway, for real, germination is what happens when seed has found an ideal condition to grow in and it starts to grow. So, first off, let's talk more about seeds since they're a major part of this. How do plants know? How do these seeds know when they're supposed to grow? Do they have a calendar? Do they have an alarm clock inside of each seed? Do they write it down? Do the parents tap them on the shoulders? It's really interesting because plants just know intuitively when to grow. And there's a few things, there's a few factors that help these plants know how to grow. And you're going to have an experiment on this today if it's something you'd like to participate in. So, seeds, however they perceive, and we don't know how they perceive because we've never been seeds, we've only been humans. They can either feel or see or smell, if you will. They can have this sensation of warmth. And so they need a good soil temperature to know whether or not it's time to grow or not. And a seed, even if it's the right temperature, might not grow because they need certain light levels. Some seeds need more light and some seeds need less. In fact, they usually need some darkness to grow. And darkness means that the seed has been buried and is in the dirt. Now, for a seed, that's a pretty good omen. They're pretty sure that if they're in the darkness, then it's time to grow and get on out there. Um, and lastly, that seed needs water. And so that hard outer part of the seed, the coating, the seed coating, is that sheath that the seed is in. Sometimes it's super hard, sometimes it's kind of soft. In the case of a bean, if you run your fingers around a bean or a dried pea, I mean, the whole thing is pretty hard. Um, and so you've got this coating that that is surrounding the seed, and this is the thing that's feeling for that temperature, if you will. And again, they're going to feel differently than we do, probably. I've never been a seed before, but I'm guessing that they feel things differently than people do. And when it feels like it's the right temperature and it's the right darkness, and then some water comes through and touches the outside of the skin, that seed kind of wakes up and is like, "Ooh, yeah, I got the sun going on, I got the water going on, I got the earth going on. It's time to get on out there." And so if it is surrounded by that nice earth, it's going to put out some roots, and then it's going to sprout up a shoot, and that shoot is going to pop up out of the ground and sprout leaves. Now that's as much as we humans can see because we are not, for the most part, in that underground environment. We can witness this by sort of tricking nature. And, in between two thin coatings of glass, we can make a little terrarium and we can put some dirt. We can grow some things right next to, we can grow some seeds in the dirt so that we can watch that process. What happens? Well, generally, those roots take root first, make a secure sort of a foundation for the plant structure, and then that shoot pops on up. And humans, we kind of do it the same way too. If we're going to build a house, we usually come up with these days a solid foundation for the house. We tend to dig it out a little bit, pour some concrete so that this house, this structure that we're going to create for ourselves, this home, is going to be solid and it's not just going to tip over. So that's what plants want to do too. They put out these roots, they're going to hold them in place, and then they're going to put up that shoot. And then once that foundation is in place, they can move on up and then create the leaves. Over the next couple weeks, we are going to talk about more about the stem, that shoot that's becoming the stem, the leaves, the flowers, things like that. Um, but for today, for germination, I wanted to tell you a couple of stories. One is kind of interesting. Hopefully they're both interesting. So, first off, seeds can last just a little bit of time. Some seeds just last for a few months, and some seeds will last for a few years, and some seeds will last for like tens or even hundreds or even thousands of years. You might think that that is absolutely bananas, but it's usually not banana seeds at all. In fact, it's usually it's like trees from the far north are waiting for the perfect growing season. They may have to wait for a few years before they have an ideal growing season to become a tree or shrub or whatever kind of seed it is. So they're going to put out very hardy seeds that can be frozen and then sort of come back to life when the ideal growing conditions are there. In fact, some humans, a group of scientists who discovered thawing out ice from the far north in way up in the far north, they radiocarbon dated these seeds to about 32,000 years that they had found this seed frozen in the ice. They thawed out the ice, and guess what? They took the seed to the ideal conditions, and it grew. It sprouted, and it actually grew up. So that's kind of crazy. For humans, that's kind of sci-fi stuff. We don't really know if we kind of dream that one day humans will be able to do that, that we can freeze ourselves and then bring ourselves back to life. That way we could get in a spaceship, go to Mars, and if it takes, dozens of years, 50 years, 100 years to get there, well, we could freeze ourselves, and then when the ship is done getting there, we would unfreeze ourselves and we'd just be able to be there. So that's one way in which we're kind of working towards essentially time travel. That's like way off topic, but similar. The other interesting story is about this guy. His name is Gregor Mendel, and he was just a farmer's kid. And unfortunately, his dad had a farming accident, which was pretty common if you were poor and you were a farmer. That happened a lot, and he was killed, unfortunately. So Gregor Mendel didn't really know what to do. His family couldn't afford to live much, and so he decided that he was going to join the church. And back then, that was an option, as if you just wanted to, if you had no idea what to do with your life, you could kind of join up with the church and seek God and find out these really amazing things. And there was a lot of money in the church, and so they would often put you through college. In fact, many of the educated people back then were because they were religious, and other people couldn't afford to go to college or go to school. So they paid for his education. It turned out he was a, a brilliant guy. So he wasn't necessarily a classically trained scientist. He was just a farmer. But he did a lot of unique things. So he became the head of a monastery, and they put him in charge because he's a really bright guy. And he was a beekeeper. He kept, at one point, up to 50 hives, and he had honey for his monastery and all of his monks to eat. And then, they'd provide a lot for the village as well. But the more interesting and relevant thing here is that he was very curious about plants. He noticed when he was walking around his fields and fields of peas that not all peas were alike. He noticed that most peas grew flowers that were white, but a few of the peas grew flowers that were pink. And he didn't know why that was. In fact, nobody knew anything about genetics at the time. There wasn't even a word for it. They basically knew that you put seeds in the ground and they grew, and that was it. The other thing is, some of these peas were fatter and some of them were not as fat. And then when he opened them up, he noticed that most of these peas were yellow, but a few of the peas were green. And it wasn't just that the green peas were coming from the pink flowers, but the yellow peas were coming from the white flowers. It could be completely random. You might have a very, very rare thing that was the rare flower, pink, that also grew this pea that was green. So that would be extra rare. Most common would be a yellow pea that grew from a white flower. So that was he was experiencing the most. So this was the first guy to experiment with GMOs, genetically modified organisms. And back then, it was more like you were just breeding things for your own personal interest. people would usually take the best seeds from a thing and breed those things and say, oh, we got a particularly good seed crop this year from this thing, so let's plant all these nice seeds, these favored seeds. Um, and so they would do that. But he thought to himself, rather than having like butterflies and hummingbirds and bees go buzzing around, he's got 50 hives of bees going around pollinating things. He said, what if I just did it myself? Um, and the other thing that was really interesting in his day was that he started actually writing down all of his observations. Now, the guy had a lot of time on his hands, right? So that's pretty cool. But he used it very wisely. So he went through thousands and thousands of experiments where he started cross breeding these plants. He would take two green peas, uh, two of these green pea bushes, the rare ones, and breed them with each other to see if he was going to get the rare bush. And for the most part, he was getting yellow pea bushes, the ones that were more common. And likewise, he would take two yellow pea bushes, and at that time, people would say, "Oh, if you take two yellow peas, you're just going to get yellow pea children, right?" So he would actually take the yellow peas and breed them, and discover that most of the peas, yes, were yellow, but some of them came out green. And then he mixed the yellow peas and the green peas, and was just like, "Well, am I going to get like a multicolored pea, or what's going to go on?" And so what he discovered was he was still getting mostly yellow peas with a few green ones. So what he was discovering was something about genetics and alleles and chromosomes and things that we don't need to get into right now, but really fascinating stuff. This building block of life, this whole DNA thing, and how do things know how to make more of themselves? How do people know how to like grow up and become people when they're little babies? There's no instruction booklet for babies. They don't have to learn how to just grow. They just grow. And so it's the same thing with plants. You have this guy is sort of tinkering with nature and saying, yeah, I'm going to breed this plant with this one with this one. And he started to um, come up with some interesting theories. He drew up a little Punnett square, which was basically, he said, um, if I have these traits and most of them are like this, that's kind of a dominant trait, right? Most of the things look this way. And you'll see that in people too. You go to certain cultures, traveling through Asia, most of the people had very dark brown hair, like you could say black hair. That is a dominant trait there. And that is like most people have that thing. And then the thing that is much more rare is the recessive trait. But the interesting thing that he sort of touched on, and maybe didn't even realize that he was touching on, although he did write about this, was that this recessive gene could be carried. So when you have the plant, it has both the dominant and possibly the recessive gene contained in that plant. So the plant has almost like a memory of what it is and what it was and what it's supposed to be. And then when it passes those things on to its kids, it doesn't always give the thing that you would expect. Um, it sometimes gives unexpected things, like when your two friends that both have brown hair have a kid, and then that kid has blonde hair, and you're like, what? How does that kid have blonde hair? That's crazy. Well, blonde hair is a human trait that has a recessive gene. It's something that's less common, but it still happens. And likewise, two people with blonde hair might have a kid, and then their kid doesn't have blonde hair. And you're like, what? How is that possible? They both have blonde hair. Well, that's just not how life works. And so, what he really figured out and discovered there with his pea fields was that we have these sort of dominant traits and recessive traits, and you pass both of those things on to your kids. And at the time, he was just playing with plants. But as scientists came to latch onto his discovery, they were like, whoa, this is actually pretty cool. They discovered that it was like that with all kinds of other things in the world, too. Things that are alive contain all of these genes and things inside of their bodies. So that was Gregor Mendel, the monk, who sort of sort of accidentally, but with a lot of intention and purpose, invented genetically modified plants. He was like, modifying these plants and keeping the ones that he wanted and weeding the other ones out. And he was actually so far ahead of his day that scientists didn't even understand what they were reading when they tried to look at his paper. He really wasn't even appreciated as a genius until after he was dead. And people were looking at his work that was published and they were like, whoa, this stuff is mind blowing, and I think we can do something really cool with it. That's it for seed germination. We're going to find out what happens after the germination as we continue on with more about roots and tubers over the next few days. Thank you for tuning in, and I will see you tomorrow.